In this video, we're going to take a look at circles in the coordinate plane. You can follow along with your activity sheet if you have it. And let's see how we can graph circles. So we know the equations of things like lines. You may know the equations of some curves like parabolas and things like that. Now we want to find out what is the equation of this circle, this green circle here. Using x's and y's, we've got our coordinate plane here, our x-axis, our y-axis, and we need to find the equations. Well, let's think about this. Here we got point B, and the coordinates here are -4, 3. And we've got point A here. Its coordinates are 3, 4. Okay. And those are 2 points on this particular circle. And if we want to find the length of these lines, well, let's try a little Pythagorean theorem. So we've got 3, 4, and let's call this r. Well, we know that 3 squared plus 4 squared equals r squared. And so we've got 9 plus 16, good old Pythagorean theorem, right? And so we square root, and we've got r is 5. Alright, so we found out that we have a radius of 5. Well, over here we have the same triangle, right? So again, we're going to have over 3 up 4. Pythagorean theorem is going to give us the same thing. It's going to tell us that AC is 5. And here we found out we should write BC is 5. Alright, so what does that mean about the length of CD? Well, since it's a circle, we know that all of the radiuses are 5. So this is going to have to be 5 also. And we don't necessarily know what the coordinates are. I know I have an x-coordinate of 2 going this way, but I don't know what that y-coordinate is because I can't quite tell what that is. It looks like 4.5, -4.5 maybe, but we don't know. Yeah, it's a question mark. But we do know that the radius has to be 5. So the length of CD must be 5 also. Well, so let's use the Pythagorean theorem here to relate these points here. Let's just call this x and y. So what we do know is that whatever the x is and whatever the y is, we know that we're going over x, we're going down y, so we know that x squared plus y squared must be equal to 5 squared, because 5 is that hypotenuse right there. So, well, we got x squared plus y squared equals 25. And there is the equation of the circle. We have an x, we've got a y, and any point that makes this true will be on the circle. All right. If you plug in the points -4 and 3, plug in -4 for x and 3 for y, it will be true. If you plug in 3 for x and 4 for y, it'll be true. If you plug in the coordinates of D, whatever they are, we don't know, but if you plug those in, it would be true. We could, by the way, since it looks like a x coordinate is 2, we could use this to solve for y if we'd like to. Well, so here we have a circle with the center at the origin at 0, 0, but now we want to look at what happens if we move the circle. So here we have a circle that is in the coordinate plane, but we have a center that's kind of floating out here. We don't know exactly what it is. Okay? And we just have a real generic circle here. We've got some point xy, and we've got some point we'll call hk. Well, we know one thing. We know that wherever we draw this radius, it always has to be the same. All of these radiuses are r. That's the definition of a circle, equidistant points from the center. So we know the distance is the same. Well, we've got this thing we know called the distance formula. All right, and the distance formula says distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. Well, let's think of these as our x2 and x1, or y1s. Let's think of these as our x1 and y1. And we know that the distance between these is r. So we can substitute. We can put r in for d, sorry. And we know that the radius is, that length is the square root of, and we'll call this our point 2, and we call this our point 1. So we're going to go x2 minus x1, which is x minus h. Again, we're just keeping this real generic. Squared. We just filled that in from the distance formula. We got y minus y, or in this case, the second y value minus the first y value, which is y minus k. And the distance formula says we add that. Y minus k. And we'll square that. And we're going to do one more thing, because we don't like this big ugly square root. Let's go ahead and square that. So we're going to square both sides. And we're going to get r squared equals, the square root will, and the square will cancel each other out. And so we have x minus h squared plus y minus k squared. Okay, so that is our formula for the equation of a circle. So that's our general equation of a circle. All right, now let's see how we use it. So a couple quick examples here. We need to find the standard equation of a circle with a center at 3, negative 6 and a radius of 5. So basically all we're doing here is plugging it in. We know our formula says this: r squared equals x minus h squared plus y minus k squared. Remember that hk is just the center. So all we're going to do is plug these guys in. Plug in h, plug in k, and plug in the radius. So we have 5 squared equals x minus 3 squared plus y minus, and our k is negative 6 here, squared. So that's going to give us 25 equals x minus 3 squared plus, and this minus minus is going to become a plus 6. And that's it. Don't overthink it. There it is. Now let's go backwards. We want to find the center and the radius of this circle here. So here's our equation. We say, well, we know our r squared is 36. So this is our r squared here. And square rooting tells us that r is 6. And then the h and k come from these 2 points here. We have 3 and 6. And notice also the symbols. Remember that our equation here, our standard form is minus h minus k. So that means that this is, h is positive 3. And so we have our hk, which is our center, gives us h is 3, and the k value here is going to have to be negative 6, like we just saw up above. Okay? Hey, in fact, it's the same thing. What do you know? Guess I didn't pick these examples too well. But there you go. All right, so going backwards, we just end up in the same kind of place there. And so there's our center. So we have our center at 3, negative 6, and our radius at 6. Well, that's how it works. Give it a try.